Hi everyone, today we're talking about map scale. So if you remember, we use scale drawings when we are trying to scale down or scale up what's actually happening in real life. So we'll normally scale down a real life scenario, like with a map when we have a huge amount of land and we're trying to now draw a smaller version of it. So in a map, they use scale specifically by using ratios. So ratios will tell us, hey, you may see, 1 inch on this map, but in reality, it represents some bigger distance. Okay, so let's look at this map here of Michigan. In this map of Michigan, we see that some cities are maybe like about half an inch away from each other. And then we see that the scale for this map shows, okay, if you see a ½ inch distance on this map, it actually means 25 miles. So they're telling you with the scale what the map distance actually corresponds to in real life. Okay, and then these map scales can be represented in different ways. They could use what's called a bar scale or linear scale. And in this one right here, the sample right here, they're basically saying that it's 1 to 316,800. Now, all that means is that in inches, each time you see 1 inch, it corresponds to 316,800 inches. And why that number? Well, they wanted it to represent 5 miles. So they basically converted the 5 miles into inches instead, and that's where that number came from. Okay, so if we wanted to prove that that's actually 5 miles, we would take the 316,800 and would think to ourselves, all right, it's in inches right now. I know there's 12 inches in a foot. So if I want to change it to feet, I would take that big amount and I would divide by 12 to get 26,400 feet. And now there's 5,280 feet in a mile. So then I would take that number, divide by 5,280, and that's how I can get it back to 5 miles. Okay, so on a map, sometimes they will write it to you like this, their scale, where the scale is showing both in inches, or they will show it to you like this map right here, just how much, your inch or your centimeters is equal to in the actual miles. There's pros and cons there, you know. I would say that the bar scale is more accurate because then you can figure out exactly how many miles it would be as opposed to kind of eyeballing it, because it doesn't really give you much, increments between these lines here. So this method may look more annoying, but it is more accurate. All right. And then the ratio that they use is also called a representative fraction. And it again tells you how many units on the Earth's surface is equal to that 1 unit on the map. So you'll often see 1 to whatever that amount is, or even written as a fraction. All right, let's take a look at example 5 from your book. It says that a distance of 3 centimeters on a map represents an actual distance of 1.5 kilometers in real life. You need to express the scale of the map in the form 1 to r, and then figure out if the distance between two schools on the map is 7 centimeters. Now you actually have to find the actual distance. In part C, the reverse, they're telling you the actual distance between two stores is 6 kilometers, so you need to figure out what the distance would look like on the map. So go ahead and pause the video and try it on your own first. All right, so for A, we need to express the scale of the map in the form 1 to r. Now remember, when you're using the scale 1 to r, they need to both be in the same units. So if I'm figuring out the scale for the map, I'm going to be using centimeters and not kilometers, because kilometers is way too big of a map. And right now I know that 3 centimeters corresponds to 1.5 kilometers. So that tells me I need to change both of them into centimeters for my map scale. All right, and I have this information on the side here. I know that 1 meter equals 100 centimeters, 1 kilometer equals 1,000 meters, or 100,000 centimeters. So I'm going to use this information right here. All right, so 1.5 or 1.5 kilometers over 1. Need to change it into centimeters. So 1 kilometer on the bottom to cancel that out equals 100,000 centimeters. So that means I'm taking 1.5 and multiplying by 100,000. 1.5 multiplied by 100,000. 100,000 equals 150,000. Okay, so that's 150,000 centimeters. 3 centimeters corresponds to 150,000 centimeters. Now I need it 1 to R, right? Because I am going to, when I'm reading the map, I just want to know what 1 centimeter corresponds to, not 3 centimeters or 5 centimeters or 6 centimeters. So I need to now change it so that the first unit is 1. So in order to do that, I can divide 3 by 3, and then that means I need to divide the other side by 3 as well. 3 centimeters divided by 3 is 1 centimeter. 150,000 centimeters divided by 3 is 50,000 centimeters. So my scale would be 1 to 50,000. Every time I see 1 centimeter on the scale, on the map, it would mean 50,000 centimeters in real life. 1 to 50,000. All right, I'm going to write that 1 to 50,000 on the side here because that's the scale of the map, so I might need that for my other information or my other questions. Now, B. If the distance between 2 schools on the map is 7 centimeters, find the actual distance between the 2 schools. All right, so using my scale, each centimeter is corresponding to 50,000 centimeters in real life. So now I have a distance of 7 centimeters, so multiply by 7. 7 centimeters on my map corresponds to 350,000 centimeters IRL, in real life, okay? So they want to know the actual distance between those 2 schools. That would be 350,000 centimeters. I could keep it like that, but nobody actually measures distance between 2 schools with centimeters, right? No one's going to be like, oh, it's 350,000 centimeters away. No, they're going to want it in kilometers so that it makes more sense. So that's just the missing last step we have to take, okay? So if I want to change it back to kilometers now, I'm going to go ahead and use my conversion. Centimeters, 100,000 centimeters corresponds to 1 kilometer. That cancels. So I'm actually dividing these. 350,000 divided by 100,000. It's a lot of zeros going on, so I have a shortcut with zeros that I can use, or I can use my calculator. That would be 3.5. Okay, so they are 3.5 kilometers away from each other in real life. Although on the map, it only shows that they're 7 centimeters away. Okay, let's move on to part C then. Erase this. They said if the distance, the actual distance between 2 stores is 6 kilometers away from each other, find their distance on the map. So now we're working backwards. Okay, we need to figure out what their distance would look like on the map. Okay, I have this scale to use, and I actually have this information up here telling us that 3 centimeters is equivalent to 1.5 kilometers. So I might want to actually use this because they're saying that the two stores are 6 kilometers away from each other. 3 centimeters, I'm actually going to use this information because it'll get me there faster. 3 centimeters on my map is corresponding to 1.5 kilometers in real life. I'm pretty confident that I can actually use that information and just multiply to get to my 6 centimeters in real life. Sorry, 6 kilometers in real life. I can take a number and just multiply by 1.5 to get to my 6 kilometers. I don't know that off the top of my head, so I'm going to use my calculator. 6 divided by 1.5. Oh, it's 4. So 1.5 kilometers times 4 gets me to 6 kilometers, which is what I wanted. So the other side also has to multiply by 4, and I get 12 centimeters. So it was basically 4 times the distance as what the problem gave us. So instead of 3 centimeters corresponds to 1.5 kilometers, we can also say 12 centimeters, 4 times that, corresponds to 6 kilometers. So then there's my answer. The distance is 12 centimeters on the map if it's 6 kilometers in real life. Boom.